Hi everyone. Let me know if the sound is working. I'm doing well, thanks. How are you doing? We said yesterday that we would look at congruent triangles, didn't we? So I don't know if you want to start off with that. I did look through the question from Corbett Maths, but it was a bit crazy, to be honest. That one. So, like, there was so much working out that I think it almost distracts from the whole point of congruent triangles. So we can always look through some Edexcel ones if you want, some actual past paper ones, specifically on congruent triangles, so you can see how it actually comes up. I think that might make more sense. Yeah, and then we can go through quadratic nth term. Yeah, I think that question was just really odd. I don't know. I know it was obviously there to challenge you, but at the same time, I think it was not super representative of what you might get. I don't know how much point there kind of was. Okay. It's not come up a whole lot. There's basically 4 past paper questions that I can find. One of which was the one in our paper we did like last week, you know, where it just showed you 4 triangles and you had to write down the letters. So that one we've already done. So the other 3 are slightly different and probably a better example. It's not just writing down the letters, you actually have to say why. So that's probably what you're looking for. So look here, question 21. This is from June 2018, paper 3. Obviously Edexcel. Okay, just in case you wanted to look at that. Sorry, it's a bit blurry. Hopefully you can read it at least. Okay. So they've told us that A, B, C, D is a parallelogram. A, B, C. Oh yeah, so like this bit here with the parallel lines, obviously. And then A, B, P, and Q, D, C are straight lines. A, B. Okay, yeah. So obviously you can see again those are parallel. And then they've said that angle ADP is equal to angle CBQ, as you can see, the 90 degrees. So prove that triangle ADP is congruent to triangle CBQ. I might see if I can highlight those. ADP, what is that? This one. Oh, that was really bad. Just so you can see which one it is. And then, oh, what was it? CBQ. Oh yeah, so the upside down version, basically. Those are our 2 triangles. So, yeah, this is question 21 exactly. So it's like pretty much right at the end of the paper, isn't it? It's only 3 marks, this part A, by the way. Normally, I feel like congruent triangles are about 3 marks. So, congruent triangles, you're trying to prove that they have 3 things in common, either 2 sides and an angle, 2 angles and a side, maybe 3 sides. If it's a right-angled one, you've got the right angle, hypotenuse side. The only thing you can't do is prove that all 3 angles are the same, because technically then they're not congruent, they could be similar. So not 3 angles, but any other combination is fine. So let's see what we've got. AD is equal to BC. A to D. Yeah, exactly. So in this one, the information that we've got a parallelogram is quite helpful. So you can say, you have to give reasons why, right? So you could say AD is equal to BC, and the reason being is because it's part of that parallelogram. Obviously in parallelograms, same as like rectangles, isn't it? The opposite sides are the same length, aren't they? So you would say something like that, opposite sides in a parallelogram are equal or are the same, something like that. In a parallelogram are equal. You have to put kind of like a reason, if that makes sense. So that's 1. We now need 2 more, right? 2 more, whether it's sides or angles, we need 2 more. So, I mean, the most obvious one, I think, is the fact that they told us the two 90 degrees. I know they've said that, exactly the right angles. I know they've said that, but like you can use that. They are inside the triangles, aren't they? So you can write down that. You can either write angle ADP, or I just tend to write it with a little kind of hat thing. I mean, it doesn't really matter as long as you're, you know, making it obvious that you're talking about the angles, which equal 90. Now that's just given, isn't it? So you can just literally, I mean, if you look at the mark scheme, it just says like given. If they've told you that, you can just give it. Yeah, the parallelogram is quite hard to notice. QC equals, yeah, let me try and draw it. QC is equal to AP. Where's that? Q to C. Oh, the other side. I guess we don't know that because that's not part of the parallelogram. Maybe if I draw it with a straight line, so I don't want to do another highlighter over the top. Let's do this, see if this is going to work. They're talking about this one here, this here, and this here. So we can only use the sides AD and BC because the other sides of the parallelogram, DC and AB, we can only use AD and BC because they're obviously opposite sides of the parallelogram, but you see how they're also sides of the triangles. But then we can't use AB and DC because you see how, I know they're part of the side of the triangle, but they're not the full side. So we can only use that reason of the parallelogram once. We don't know the line AQ and what's that? BC, I think. I don't know if we know that they are the same, so I don't know if we can say that about the top and the bottom, if that makes sense. So I was thinking more so, obviously parallelograms, you've also therefore got parallel lines, haven't you? So if you think about angles on parallel lines, you could also use something like that to find angles. So my thought was another angle. So we've got one side, we've got one pair of sides, one pair of angles. So we need one more thing, right? We need three things. So I was thinking maybe to look at angles. If you have a look, let me try and draw it. This angle there, which is inside the parallelogram, is also inside the yellow triangle, right? And then do you see how then this one here is inside the parallelogram, also inside the green triangle? So I would probably state that those are the same because opposite angles in a parallelogram are the same, aren't they? So I would probably use that information there. What we say? QC and APR on another parallelogram. So the thing about parallelogram is that you've got, let's say, the top and the bottom are parallel, which in the case of the double arrows is true, the one you're saying. But in terms of then those sides, so what was it? QC. Yeah, QC and AP are parallel, right? But we don't know about like this bit and this bit. We don't know if those are parallel. They haven't told us that. So it obviously looks like they are, but it doesn't tell us that for certain. So I'm not going to kind of lean on that. And to be a parallelogram, you need to have the top and the bottom are parallel, and then the two sides are parallel, if that makes sense. So two pairs of parallel sides, not just the top and the bottom. Because maybe it's like a trapezium or something instead. I know it looks parallel, but they haven't said that, so I'm not going to rely on it. So I'm going to go with those two angles there because they are inside the parallelogram and they're also inside both of my triangles. So what was that? Well, you can call it whatever you want, whatever letters, as long as I went with D, A, B. You might call it, I guess we could call it up to P because that includes the whole triangle, doesn't it? Let's do that. Let's do that. D to A to P, or P to A to D, whichever order, is the same as then B, C, Q. And then because opposite is kind of the same as the previous example, except instead of sides, we're saying angles. Opposite angles in parallelograms are the same, aren't they? Are equal. Parallelogram are equal. Now you do need a conclusion once you've done all three and given kind of a reason. No, that's fine. I was just doing it in terms of the highlighters. I was just doing it to kind of show you. Oh, I was just doing it to show you, okay? You don't have to highlight it in the exam. It was just so that you could see which was the two triangles and then where was the parallelogram, that was all. So we've done that, but you do need some kind of conclusion, right? So you get 2 marks for doing 3 reasons, but we do need a conclusion. Now, I don't know about other exam boards, but in terms of Edexcel, they're fine for you to just use the acronyms. So I would put kind of like, therefore, congruent. And then you say why. Yeah, we've got 2 angles and a side, haven't we? Exactly. Yeah, it will finish probably a bit before 7, because at 7 I'm going to do a past paper. So I need to kind of set that up. So maybe like 7:15, 10:50, depends. Or until anyone doesn't have any more questions, basically. So yeah, I would put, as you said, angle, side, angle. You can, as I said, on Edexcel, you can actually literally write ASA. Like, you don't have to write out the whole thing if you don't want to. Yeah, that's what I'm doing. It's going to be an actual past paper at 7 o'clock. This one now is just random questions, and then at 7 we'll go through a specific past paper, which I think is the June 2019, if I didn't get that wrong, paper 1. So you have to write this conclusion, right? That is going to be your final mark. You have to write the conclusion. Okay, there was a part B, but it's not relevant to congruent triangles, so I'm going to skip that. Okay, so you need to prove 3 things are the same, give reasons why, and then say, therefore, congruent because of, ASA, SSS, SAS, or the right-angled one. You could also use. Yeah, no worries, guys. Hopefully it's helpful for you. This is question 22. Again, you can see we're at the end of the paper. What paper was this? November 2019, paper 1. Oh, we'll probably be looking at this later on this week then. So you've got, in this case now, the context is not parallel lines, parallelograms. The context is now a circle, isn't it? So you're thinking circle theorems. So they've given us AEC and DEB as straight lines, which you can see they cross through each other. Triangle AED is an equilateral triangle. Okay, this one here. Doesn't really look like it, but they've said that it is, so that's fine. Prove that triangle ABC is congruent to triangle DCB. Make my highlighter a bit smaller. So triangle ABC. Oh, okay, yeah. That one is congruent to DCB, which is then this one. Okay. I mean, this one is a kind of easy one to start with, given that they both share a side. You see how they both share BC? So that's obviously the same side. So you could start with that if you wanted. This one is 4 marks, by the way, so we've got an extra mark here. So you could say that BC is common in both. So that's obviously a side that's the same. Yeah, exactly. Yeah, BC you could say, because they both share it, so it has to be the same, doesn't it? BC shared, or BC in both. However you want to write it. It doesn't need to be a whole full sentence or anything. So that would be, I mean, even just writing that would be 1 mark, even if you weren't sure where to go after that point. So what else could we do? I think there's quite a few options on this one, actually. So because it's circle as well, think of circle theorems. I'm thinking maybe these 2 angles. Because of, the circle theorem, angles in the same segment are equal. Opposite angles in a quadrilateral. Oh, a cyclic quadrilateral. Yeah, opposite angles in a cyclic quadrilateral specifically add up to 180. But which opposite angles are you referring to? Because we'd have to specify. So I think I'd go with CDB is the same as CAB. B. Do you see how they both start and finish at C and B? That's why it's the same segment. So I would say that. Now we need one more. I think you can use angles in the same segment for multiple of them, actually. If you look at it from a different angle, technically, wait, no. Yeah, you could work out, because they've obviously mentioned there's an equilateral triangle, right? We haven't actually used that information yet, have we, either? There's also that to consider. There's like 5 different ways to do this one. So congruent is when the triangles are identical, same size, same shape, same everything. They're literally the same exact triangle. Maybe one's rotated though. Angle A, so EAD, E to A to D, right, is 60. Yeah, I feel like you could use, obviously they've mentioned the fact that it's an equilateral triangle. We've got to use something like that, haven't we? In there, I guess. So obviously equilateral triangles, all of the angles are 60, as you said. 60. Oh, not that one. That one there, 60. And then therefore this one would also be 60. But that would also relate down here, because you know the angle fact about opposite angles or vertically opposite angles? Vertically opposite angles are the same. So like that one, do you see how opposite here would also therefore be 60? DAC, where's that? Oh wait, hang on. DAC equals DBC. DAC equals DBC. Yeah, exactly. That's also the same. This one here is 60. This one down here is also equilateral because of it relating to the other one. So do you see how then we're actually given this angle inside the two triangles here? So you could say that. You could say these are both 60. So what's that? Angle ACB is equal to angle DBC, which is 60. In this case, we've actually worked it out. Also, if you draw on it, they do take that as working as well. So we've got BC, we've got this angle, and then yeah, they've said that you can use your pairs of equal angles could be actually shown on the diagram as well. They will accept it if you can see it. So there's that as well if it's not written fully. You can see it on the diagram, but I would just make sure that it's obvious. Now in this one, I think you could have done angle, side, angle, side, angle, side, or angle, angle, side. There's kind of loads, yeah. There's loads for this one particularly. DA and AB. D to A, and then A to B. Yeah, I mean, individually they are straight lines. But I don't know like how that would relate. So for my one, because I chose an angle up here and then I've got the angle down here and then a side down here, I think mine would be angle, angle, side. It depends which one you've chosen, because if it was angle, side, angle, which they have offered as an answer, you would have to have the side between the angles, which I don't have because I chose this angle up here and then this angle down here, didn't I? And then the side here. So mine would be angle, angle, side. But if you figured out a different one, you might have angle, side, angle, which is fine. You might have side, angle, side if you've got two sides, because of to do with the equilateral triangles. Technically DB and AC are the same side because of the equilateral triangles. You could use that. So it just depends. This one actually had a load of different answers. But as long as you've got three things that are the same, and then obviously proven why, and then give your conclusion. So hang on, therefore congruent, and my reason for me, particularly because of the one that I did, was angle, angle, side. So it just depends which one you have. Okay, so actually that was the only ones I had. I think the other one I have is actually not what I thought it was. Yeah, those are the only two that I've got, and then the other one was, as we said in the other paper we recently did, where you just had to choose, which one was it, triangle A and D. You didn't have to explain why they were congruent, you just had to choose them. So yeah, it doesn't come up a whole lot by the looks of it, but yeah, as long as you can follow the structure of finding some kind of combination of sides and angles, then you can prove that it's congruent. So either side, angle, side, angle, side, angle, all three sides. You can't do all three angles though, just remember that. Or sometimes it's right angle, hypotenuse, side. So those are the options that you could have to prove congruency. Okay. But yeah, it doesn't come up a whole lot, so it's not something I would kind of stress out about. Okay, the next question was quadratic nth term. Whoever wanted to go through quadratic nth term, do you still want to go through that? If not, then I'll move on to the next one. The next one after quadratic nth term is basics of probability. Yes, you're still here. Perfect. Okay. We'll do quadratic nth term. Quadratic nth term, I think, is quite nice. You just have to memorize certain things. Once you've got that memorized, the method is consistent every single time. So let me just grab a question. It's normally about 3 marks, so quite nice. Quite a nice question. This one is from November 2020, paper 2, so it is calculator, but I don't think you really need a calculator, to be honest. November or June 2020, depending on what it lists it as. Okay, question 16. So these are laid out quite nicely as well. So here are the first 5 terms of a quadratic sequence. They've told you that it's quadratic. And then find an expression in terms of n for the nth term. Okay, so this is just a method you just have to memorize, right? You just do the same thing every time. I know other people do it differently, but this is how I would do it. So I'd work out what we'd call like the first difference. So the difference between them, right? So that would be, for that one, 11. What's that then? 17? Hopefully I'm not calculating this wrong. This one is calculated, so we might as well double check. 23, yeah, and then it looks like 29. 90 minus 61, yeah, 29. So obviously your first difference won't be the same because it's quadratic, right? It won't be the same. So therefore you then need to go and do the second difference. Now the second difference should be the same every time. If you don't have the same number, something's gone wrong. So you can see here we've got 6, 6, and 6. So that should be the same. So you first of all do that. Once you've laid that out, this is the bit then you need to memorize. So we start at the second difference. So in this case it's 6. It could obviously be a different number every time. That one you have to make sure you remember is equal to 2a. Just memorize 2a is equal to that one. So in this case, it's 6. So do you see how I could solve that? That's just an equation, isn't it? If I divide by 2, a is 3. And then, so there's 3 things you need to memorize. This is one of them. Then what we do is we jump back up. Let me get a different color. You always stick on this left-hand side, right? Jump back up. Get a different color, maybe that one. Your first difference, but it has to be on the left-hand side. It can't be the 17, the 20. It has to be this one over here, right? That one you have to memorize is equal to 3a plus b. Now, the reason why we're doing it in this order, like backwards, is because obviously you can't solve an equation with 2 letters. But because we already worked out what a was, now we can. So if I substitute in a, which is 3, do you see how I can now work out b? So that's 9 plus b is 11, so you can see what b is. I would just solve that to get 2. And now the last one you need to memorize. So then you jump back up to the first term in the whole sequence. So it has to be, again, on this left-hand side. That one you have to memorize is a plus b plus c. Again, you see why we had to do it in this order, because you couldn't solve it if you didn't know what a and b was. We now know that a is 3, we know that b is 2. So do you see how I can work out c? Just kind of solving equations, basically. As long as you memorize these 3 equations, c is 5. Now, you're thinking, well, what is a, b, and c? Well, quadratics generally is, well, obviously in terms of nth term, we're using n, but you always put the a in front of the n squared or the x squared, depending on the context, plus bn plus c. So you see how now I can just slot in those numbers? So that would be 3n squared plus 2n plus 5. Obviously, if you get negatives, put the negatives in. The paper today is at 7. Okay, this is just a random Q&A, but the paper that we'll go through is at 7 o'clock. Yeah, quadratic nth term is really nice as long as you memorize whatever method you want to use. This is my method. You might have a different method. That's fine, whichever works for you. I quite like this because it's just consistent, and I just memorize 2a, 3a plus b, and a plus b plus c. As long as you can memorize those 3, then you'll be fine. So you see how quickly that was, like how quickly I can do that. Today I think it's the June 2019, if I'm not wrong. Paper 1, obviously. Let me just check. Yeah, you just repeat that for any question, literally. Sometimes you might end up with a 0 for B, for example. Then it just means that there isn't one. So you would just skip B. You just wouldn't, like if you end up with 0 for B, then you just wouldn't write the middle bit, right? That's fine. Or if you end up with 0 for C, you just wouldn't have a C. That's fine. Obviously, you're going to have an n squared because it's quadratic, but the other 2 terms you might not have. So you might not always have all 3 terms at the end. Try and see the front of this paper. Where is it here? Yeah, June 2019, paper 1, higher tier, Edexcel. That's what we'll be going through at 7 o'clock, okay? Okay, yeah, I know there's different ways to do it, so maybe you've got a different method, which is fine if that works for you. Yeah, that's fine. Does that make sense, or do you want me to go through another one? It's the same exact method, though. I just apply it to a different question. But yeah, you can see someone else in the comments has written a different method. So if this method doesn't make sense, you can obviously have a look on elsewhere on YouTube to find a different method. I think there are different ways to do it. Just depends what your teachers have shown you, really. I just got shown this one, and it worked quite well for me. Yeah, now it's okay? Perfect. Okay. All right, so after that, we said some basics of probability. Probability is a bit random, so I'm just going to bring up, you said kind of level for grade 4, grade 5. So I'm just going to bring up some like just easier probability questions, and I guess the basics will come up in those questions. So probability. I do have a video that's like most common, or what did I call it? Most repeated Edexcel probability questions. So obviously some of those at the start of that video are kind of the level 4, 5 ones anyway, grade 4, 5 ones. So you can also have a look at that as well. Predictions for paper 1. It's not predictions, but what I did do, and actually the video I think is coming out at the end of this week. I think it's coming out on Friday. is I've been through all of the non-calculated papers, and again, I'm focusing on Edexcel, right? I've been through all the non-calculated papers, and I kind of looked at what questions came up and kind of did a tally of each topic and saw which ones were the most common. So I have done that. Now I can read out the list if you want. Oh, yeah. Let me print screen this. So it's not necessarily that I think they're going to come up, it's just like this is what comes up quite a lot. Obviously, some of them could come up on paper 2. It's not, you know, guaranteed. This is my list of what I would say is quite common, is what I would say for paper 1, quite common. So decimal calculations, that means multiplying and dividing decimals. Fractions operations, again, multiply, divide, add, subtract. This is a lot of mostly mixed numbers as well, improper fractions, mixed numbers. Highest common factor, lowest common multiple, you know, when you do the factor trees, product of prime factors, that thing comes up. Obviously, that could also come up in paper 2, right? It just depends. But that does come up quite a lot. Maybe some percentages, just reverse percentages maybe, but also percentages. Just make sure you know how to make percentages or work out percentages with no calculator. Cumulative frequency or box plots, kind of one of those two. Mostly cumulative frequency. Now, obviously, that could come up on paper 2 or paper 3, but I feel like it seems to come up on paper 1 quite a lot. Index laws, obviously there'll be a decent amount of index laws because, again, they don't want you to use the calculator for that. Again, same with negative and fractional indices. That will likely come up because they don't want you to use the calculator for it. Algebraic proof seems to be something that comes up a fair amount. Bit of a random one. I have got a video on that separately anyway. What I noticed was area with algebra. So, you know, when they combine area or maybe perimeter or something like kind of shapes with algebra and they put like x plus 2 as the side length, something like that. That tends to come up quite a lot. Again, I have a separate video on that. The volume of cones and spheres or maybe hemispheres, that comes up quite a lot. Obviously, that could also come up on paper 2 or paper 3, right? But if it comes up on non-calculator, they won't make you work out the pi. They'll just say, give your answer in terms of pi. So that could still come up. Recurring decimals to fractions could come up. Proportion seems to come up a lot on paper 1 for some reason. But again, it could also come up on paper 2. I mean, there's nothing to kind of dictate which one it will come up on. But just from past papers that I've looked at, function seems to come up quite a lot. This is kind of roughly in order of difficulty, right? Solving simultaneous equations. I put graphically here, but also just simultaneous equations generally. So it could be linear. They're both linear, which will be at the start of the paper or like the middle of the paper. It could be one is a quadratic, one's linear, which is at the end of the paper. Or it could be solving them graphically, you know, when they're already on the graph and you just have to find where they intersect. So anything to do with simultaneous equations, and then obviously a bit of surds at the end. So that's my list of kind of, like if I were to make a prediction, obviously that doesn't cover all of the questions, right? There's not 20 questions there, but still, that's kind of what I think is the most common. This is for Edexcel. I can't necessarily speak for other exam boards, right? Because I haven't looked through those. I would assume it's probably roughly similar though. So that I will have a video on Friday that comes out. It's about 45 minutes long, and I'm doing like a question on each of these topics basically from past papers, so from Edexcel past papers. So that should be quite helpful as well. But that's on Friday. It's not a live, it's just an actual paper. Well, not paper, it's an actual like video that I put together. Okay. Hard questions. I don't know. The hard questions are normally a bit random, aren't they? It's normally something to do with shapes, I guess, like you said. Yeah, it's a bit hit or miss, that, I guess. Loci and construction barely ever comes up. I think it has, but just not very often. It's not that hard either, to be honest. It's really not. It's not really that difficult. Once you know kind of, I think there's only 3 or 4 different things they could ask you to do. Once you memorize those, then it's fine. But again, like you said, it doesn't often come up anyway. Yeah, I'm pretty sure there's been loci ones. You know when it's like, there's a pathway and there's a tree and there's something in the field, like that's kind of the thing I'm thinking of. Yeah, circle film is quite hard. Okay, right, so do you still want to have a look at some probability ones? Just some kind of the lower level probability ones. Where did I put it? Here. It's more, I guess, information about that all probabilities add up to 1. Make sure that you know how to use a probability tree, because that's very consistent, that one. Venn diagrams, things like that. So I think one of the common questions that I got, let me find a slightly harder version of it. There's quite a common question where it's like a table of probabilities. It's normally at the start of the paper, a table of probabilities, and some of them are missing. That's quite a common Edexcel question, so I'm thinking that's probably quite a good one to look at. Again, it's on my video of most repeated probability questions if you want to also have a look later as well. So we've got, you see here, literally question 6. So this could even be the end of the foundation paper, because normally, at least with Edexcel, the first maybe 5 questions, sometimes 6 or 7 questions of your paper, higher tier, will be the last 5, 6, 7 questions of the foundation paper. So it literally, like those first, definitely 5 questions, maybe up to 6 or 7, overlap. So the first few questions on the paper are technically the hardest questions in the foundation tier, if that makes sense. So I would say this could easily be asked in foundation tier, right at the end of their paper. So this is quite common with Edexcel when you have this kind of table and there's missing probabilities. I think that's quite common. So here there are some counters in a bag. The counters are red or white or blue or yellow. So you see obviously here 4 different colours. Bob is going to take at random a counter from the bag. The table shows each of the probabilities that the counter will be blue or will be yellow, because obviously we're missing red and white. They happen to just mention that there's 18 counters, 18 blue counters, so I'll just leave that there for now. The probability that the counter Bob takes will be red is twice the probability that will be white. Now, sometimes they say it's the same thing. It's the same probability. Sometimes they say that it's twice. This is obviously a bit harder. That's why I chose that one. So part A is to work out the number of red counters. So not even just the probability, but the number. This is 4 marks. So the kind of basics of probability here that you need to know is that all probabilities add up to 1. So this whole row should add up to 1, right? Because obviously that's like 100%, isn't it? You can't have more of a chance than 100% of something. Now, what I do with this one when it's harder, when they're obviously if they were equal, you would just subtract that and then half what's left, wouldn't you? Is I always label X as the one that is. You can use ratios as well. I don't really like ratios, so I tend to avoid it. I use algebra instead. So red is twice the probability of white. So white is the smaller one, right? I would put white as X, therefore red is 2X. Now I'm going to use the same letters because I've only got one equation. Then do you see how I could create that equation? Because I know the fact, like the mathematical fact that I'm using here is that all of those probabilities must add up to 1. So that's a key thing to remember. All probabilities always add up to 1, can't be more than 1. So there. Now this is paper 3, so you can actually use a calculator. So yeah, obviously then I would just go, well, that's 3x, add that together, what's that, 0.7? Again, use a calculator if you want to. Probably best not to guess it. And then you can just solve it. That's how I would do it, because I quite like to use algebra. I like to have that structure. You might be able to do it just by figuring it out in your head, that's fine. 0.3. Oh, what's going on with my pen? So then x is obviously 0.1. So then do you see how I could work out, therefore, that white is 0.1 and then red is actually 0.2? So that's the probability. Yeah, exactly. You're just looking at the comments. Yeah, you're right. Create an equation. That's what I do. I always put x. When there's things I don't know, I always put x as the smallest one. And then if there's something that's like a multiple of it, I'll put 2x or 3x or whatever. Now, that's obviously the probabilities, but they've asked for the number of red counters. So we also need to know how to translate probabilities into actual quantities of counters, right? Now, that's why they've given us that blue bit. Do you see how we know that blue is 0.45, but we also know that it's 18. So this is what I was saying about, in my head, this is reverse percentages. You might not make that link, but in my head, it's like reverse percentages. Because 0.45, if I were to write it as a percentage, you don't have to do it like this, but again, this is just how I look at it, is 45%, isn't it? 45% of all the counters, is it counters? Yeah, counters. Is 18 counters, isn't it? So I want to know obviously how many red there are, but also I guess because 45 is quite an odd number, it's not really an easy number to figure out, I would want to work out all of them. So when I say reverse percentages, what I would do is I'd reverse, normally you multiply, don't you, to make a percentage. I would reverse it, so divide by that decimal. Now if you do that in your calculator, let me get the calculator so you can see. Hang on. Here. If I do that, 18 divided by 0.45, it's going to give me a bigger answer. Do you see how the answer, this is now 100%. That's 40. So now there's 40 counters in total. So then all I need to do to find the red is just kind of like percentages in the correct direction, isn't it? Not reverse anymore. I want to know what 20% of 40 is, which you could work out yourself, or you could just do it normally by timesing. Again, get this back. 40 times by 0.2 is 8. So the answer's 8, but there's kind of two things there. The first thing is knowing that all probabilities add up to 1. That's the first thing. So you can create that equation. You don't have to, as I said, you don't necessarily have to use algebra. If you prefer to use ratio, it'd be like a 2-to-1 ratio, wouldn't it? 2-to-1. You could do that. I just don't like ratio, me personally. I don't really like ratio, so I try to avoid it. And then it's also going, well, how can I translate between probabilities and actual numbers, in this case of counters? So that's the second half. So that's a very common question, I think. I know you just said you're doing AQA, so I don't know how much this would correlate with AQA, right? Because I'm kind of mostly experienced with Edexcel. So it might be good for you to maybe have a look at some videos or some tutors that maybe on YouTube do AQA past papers. That might be more helpful, because Edexcel is, obviously it's the same content, right? The syllabus is the same, but I feel like the way they word the questions is very different. AQA words it very differently, and you do need to get used to that, is what I would suggest. So there's that. That's a very common one for Edexcel. I don't know about AQA in that case. I'm thinking, obviously, probability trees. Right? Which, again, would be kind of the same logic in both. If I can get a probability tree one. I'm just going to try and pick a nice one, right? Let me copy it. And then there's also Venn diagrams. I mean, obviously beyond that, probability can come up in really random ways, but kind of if I'm trying to think of the most structured questions, the most straightforward questions, it's those ones. So we'll get a probability one, we'll do a Venn diagram one, and then we can have a look at another question. Let me see if it's going to let me print screen it. This is literally question 5. So again, this would have probably been at the end of the foundation tier paper as well. So we're talking, as you said, like grade 4, grade 5 stuff. Yeah. So probability trees I quite like because they work the same way, as long as you memorize kind of what calculations to do, it's all the same. So quite common, they'll ask you to fill out a tree, and then part B, they'll ask you to actually do something. Oh yeah. We can do that one as well. Yeah, the one you've just mentioned, that's fine. So I'll quickly do this one. This is question 5. So Amanda has 2 fair 3-sided spinners. You can see here, 1, 2, 3, 1, 2, 3. They both have the same. Amanda spins each spinner once. So you can see obviously one branch is for one set of branches is for spinner A, and then the set of branches here is for spinner B. Complete the probability tree. So in this case, I would probably use, you can obviously use any fraction, decimal, percentage. I personally tend to use fractions if they haven't told me otherwise. That's just kind of my personal preference. This is a calculator one though, so if that helps. So I would say, right, the probability that it lands on 2, do you see how there's only 3 options, and 2 is one of those options? Now, they've said they're fair spinners, so they're all equally distributed. So the probability that it lands on 2 is one possibility out of 3, isn't it, for that first one? Now, the option that it doesn't land on 2 is obviously then the other 2, isn't it? 2 out of 3. Now, the information about a probability tree that you need to know is that these branches, so this one here, must add up to 1. This is back to what we were saying about probabilities adding up to 1. This one here has to add up to 1. This one here has to add up to 1. So all of those 3 individually add up to 1. So you see how 1/3 and 2/3 make 3/3, which is 1, isn't it? So you can also use that as your to help you. Now, looking at then spinner B, whatever happens to spinner A does not affect spinner B, does it? They're completely different spinners, so it doesn't really matter. We're looking at spinner B, we've got exactly the same, haven't we? So it lands on 2 is still 1/3, and not 2 is still 2/3. And down here, same thing again, because whatever happens for A does not impact B. Now, your question that you said probably does affect it, so we'll have a look at that as well. So that's 2 marks, that's quite nice. Now, part B, work out the probability that spinner A lands on 2 and spinner B does not land on 2. I usually highlight my options. I know that in the exams you probably don't have highlighters, but you can maybe just draw like squiggly lines or some kind of thing to identify which branches satisfy the question that they've said. So they've said the probability that spinner A lands on 2, so I have to follow this branch here. And then spinner B does not, so then I have to follow this branch here. So when you're working out probabilities within a tree, you see there's 2 branches, obviously. You always multiply between the branches. So in this case, I would do 1/3 multiplied, not add, multiplied by 2/3. So, I mean, it's calculated, but you can also just work it out. It should be 2/9. Now, that one, there was only one pathway, wasn't there? There was only one option because of the way they worded the question. Sometimes there's multiple options. So you might have highlighted that one, but then you might have also highlighted down here, for example, and then you'd work out separately the green option. When you've got multiple options at the end, see here 2/9, let's say we had another option for the green one, at the end, you add them together. In this case, I'm not adding anything because I only had one option, didn't I? So I didn't need to add anything. So that's, as long as with probability trees, you know, each of these kind of branches that are together must add up to 1, that one, and that one. When you work between the branches, you multiply. If you've got multiple options at the end, you add. So probability trees in that sense are quite easy. But let me just have a look at the question you've given me. We can draw our own tree. Sometimes they don't lay it out for you. Sometimes they just leave it blank and you can draw it yourself. So you've said a bag contains 8 balls. 3 are red, 5 are blue. Two balls are taken from the bag without replacing. Hang on, work out the probability that there are at least 2 red balls still in the bag. That's interesting. At least, I'll write it down so we can all see. Yeah, I've not seen that, like still in the bag. Still in the bag. Okay, so I'm going to draw a tree. Whenever there's like an event, like 2 events or 3 events, so in this case there's 2 balls they're going to take. That's 2 events in my head, or maybe 3. I like to draw a tree. So obviously we've got either red or blue, and that's the first ball there, isn't it? That's my branch for the first ball. Now we obviously need to translate these into probabilities. Again, I would probably use fractions in this case. So I would do, for red, it's obviously 3 balls out of 8, isn't it? Do you see how that's now the probability? And then blue is 5 out of 8. And then that's my first one. Let me move this down, actually, just so I've got some space to do the second one. And then obviously for the second one, now this is the bit where you said without replacing. So this is where our probabilities will change. This is a bit harder than the previous question we just looked at. So then you've got to think about it. Let's say I'm following this branch here. So imagine you've already taken 1 red ball. How many do I then have left in the bag? Well, only 2 red ones, but also there's not 8 balls in total left in the bag, is there? There's only 7. So do you see how that would affect it? Whatever happens with my first ball is going to affect my probabilities for the second one. And now for the blue, because I did take a red one, there's still 5 blue ones, but it's still then out of 7. And you see how now this set of branches also adds up to 1 still. 2 out of 7, 5 out of 7. That makes 7 out of 7. Okay, so just kind of work through it logically. And then down here you go, well, I've taken my first ball as blue, so then I still have 3 red ones. But again, it's out of 7 because I have taken a ball out of the bag. And then blue, I took a blue one already, so I've only got 4 left. So that's my tree. Now we're actually going to work out the probability. Now you can worry about what they've said. So work out the probability that at least 2 red balls are still in the bag. So now I'm going to highlight the options that would give me that. So there's 3 red balls. So that basically means I can only pick 1 red ball, isn't there? So I could pick red first. Hang on, let me make this a bit bigger. So you can see the highlighting. I could pick a red ball first, couldn't I? But then I couldn't pick another red ball because then there'd only be one left. So I would have to pick this one, the blue. The other option is that I pick blue first, but I could also then pick a red second, couldn't I? Because there would still be two left. Okay? Now, there's actually a third option though, because it says at least. At least two would mean either two red balls, or maybe there's still three in there. So I could also pick both blue, couldn't I? Because there would still then be three balls in the red balls in the bag, which is then at least two, isn't it? So do you see how that's my options there? I like to identify the options that satisfy the question before I start working it out. Now, you've got two options here. Do you see how we've highlighted 3 out of 4 possibilities from that tree? You can either go through and work out all 3 of those separately and add them at the end. If you want to be a bit faster, you can identify that the only option we didn't choose was red and red. So if you want to, this just depends if this is more complicated for you, right? If you want to, you can work out the probability of both red and then subtract it from 1. Because again, remember, all probabilities add up to 1. But just remember you'd have to subtract it. Now, I probably wouldn't do that because I feel like I'd get confused, but that's up to you. I would rather just work it all out systematically. So that's what I'll do now, but I'm just mentioning that you've got that. Okay, so the green option. Again, as I said, between the branches you multiply. So the green option would be 3/8 multiplied by 5/7. Just multiply straight across, right? So 15 at the top, 56 at the bottom. I wouldn't worry about simplifying anything because at the end we want to add them. And if we leave it as this, then we will have the same denominator. So it'll be easier to add. So 5/8 for blue, I'm doing blue now, times 3/7 is, again, 15/56. And then the last one, which is the yellow option, 5/8 times 4/7 is 20/56. Now, do you see how I've got 3 different possible options of what could happen? There's 3 different possibilities, right? So at the end, I know the previous one we only ended up with one answer, didn't we? So we didn't need to do anything. In this case, there's 3 possibilities. So what you're going to do is just remember you always add, which is why I left it with the same denominator, because all I need to do is add the numerators now. So 15 plus 15 is 30, plus 20 is 50, 50 out of 56. Again, that's less than 1, isn't it? Because all probabilities must add up to 1. Okay. You don't have to simplify it normally. It depends on AQA, I'm not sure, but I know in Edexcel they don't tend to make you simplify. If you wanted to, you could. That would simplify, wouldn't it? I think you could half it. What, 25 out of 28? That's probably the most you could simplify it. I would just leave it as a fraction. I wouldn't even worry with decimals or anything. It's alright, guys. I'm just doing this for Gina, basically. So as long as... Does that make sense? Does that answer your question on that one? Yeah, sure. I know because you're from the US, right? I know in the UK, normally if it's a non-calculator question, you would just put pi as a symbol. If it said estimate, you would use pi as 3. But other than that, if it was a calculator paper, then you would actually work out the value with, putting pi in your calculator. But I don't know in the US, I don't know what they would want. You have to, it depends on what your exam system is working as. Okay. Yeah, so, okay, hang on, let me just see what else. So, I don't know if you want me to go through a Venn diagram one as well, just to cover all bases, or are you okay with the Venn diagrams? And then if not, then we can move on to the next thing on the list. I've lost track a bit here. Oh yeah, I think loci was our next topic, wasn't it? Now I'm looking back. You're fine. Okay, we'll do a bit of loci. It doesn't really come up, so again, I wouldn't be like too stressed about it. Again, I'm talking mostly for Edexcel, right? I'm not necessarily sure about other exam boards. What topic did I even put it in? Oh, construction and loci, yeah. Oh yeah, there's like one past paper question. There's literally one past paper question on this that I've got. Not necessarily including the last couple of years, because I don't think I've looked through those yet. 2 marks. So again, you might just decide this topic is worth skipping and just, gain the mark somewhere else. Because I mean, I don't think anyone's really aiming to get 100%, right? So there are certain topics that you could decide, you know what, if that comes up, I'm just going to give it my best shot, but otherwise I'm going to focus on other things. That's up to you for your exam strategy. So this one, you can see it's question 4 as well. We're literally kind of still in foundation territory here. So use a ruler and compasses to construct the line from the point P perpendicular to the line CD. So basically, I'm pretty sure for this one, because you see how P is not halfway between C and D, you have to create a kind of halfway point. Or at least you have to figure out kind of an equal distance. So what I would probably do in the case with a ruler, I'd probably measure maybe from, trying to think what I would measure. You basically need to get to a point over here, kind of where it's an equal distance with D. That's the thing, because C is obviously way over here. That's the problem with C. So I think you could. I don't have a compass, obviously, digitally. That's the only thing that I'm kind of worried about. Try and demonstrate it. That's the problem with demonstrating it. I don't have a compass, but I can just do arcs as best as I can, basically. See what the best I can do here. If not, we can also look at some from Maths Genie as well, because I think those are quite similar to Edexcel. Like, I think they do a quite a good job on that website of finding some that are similar to Edexcel wording, so that's quite handy, I would say. But yeah, I think there's 2 different ways to do this actually, now that I've seen it. Okay, one way that they've done it is they've just drawn an arc, like an arc from, you put your compass on P, they've drawn kind of like an arc. Imagine that was, actually an arc. They've drawn it from there. And then what they've done is they've kind of taken this point and this point. That's what some people have done. But I know it doesn't look equal on mine, because obviously on mine I've not drawn a proper arc. But let's say you had. It would be an equal distance. P would be kind of like in the middle of that if you did that properly, from putting your, the point of your compass on P and drawing an arc. Just make it big enough that it does go through, obviously, the line. And then you can get your compass and put it on both of these points, and then it ends up kind of drawing 2 points like that. Yeah, it doesn't really come up that often. That's why I'm not even that worried. Yeah, you can draw it smaller. Again, it just depends how you want to do it. What was this from? This was from November 2019. This wasn't even on the June paper. This was from November as well. So it's actually not even come up on any of the June papers, which obviously because you guys are doing June. So technically they could have said that last year. They could have said, oh, it hasn't come up yet, so it will come up this year. But then it didn't come up again. So, I mean, who knows? Like, it might come up, or they might still decide that it's not something they want to test out. This is obviously one of them. This is construction more so than loci, right? This is construction, but the loci one that I was thinking of, I think maybe if I find it from Maths Genie. I don't think you can really predict, that's the problem, because you just don't know. It's not come up on any of the June papers at all. So every year they probably said the same thing, oh, it's not come up yet, so it might come up this year, but then it didn't again. So like, who knows, honestly. I basically think you need to know how to construct like a perpendicular bisector, a triangle, an equilateral triangle, I'm pretty sure. That's constructions. Where's the loci bit? Oh, here. This is an example. This is from Maths Genie, right? This is not from a past paper. As we said, there haven't really been any. Right, let me download it. It's got stuck. Yeah. Let me just reset the whiteboard. Loci is more like this type of thing. You're going to see the top of that question there. So here's a scale drawing of a garden. The scale is 1 centimeter to 2 meters. Obviously, I guess my scale might be different to that, but that's fine. So a tree is going to be planted. The tree must be more than 4 meters from the patio, which is a straight line. And the tree must be more than 6 meters from the pond, which is just a single point. So what I would do, you just have to know when to draw lines and when to use your compass. Because the patio is a straight line, I would obviously use my ruler to measure, and obviously you have to convert it to the scale, right? They've said 4 meters, so they've said 1 centimeter. Hang on, let me draw that lower. I think that's out of the picture. 1 centimeter, they've said, is equivalent to 2 meters in real life, so they want 4 meters. So that would be 2 centimeters from there in your picture. So you would measure 2 centimeters and just draw literally a line. So I don't know. I'm just going to guess. I don't know what the scale is, but you would measure it, obviously. Let's say that was 2 centimeters in your on your piece of paper. And then the pond is 6 meters, which in terms of actual centimeters would be 3 centimeters. So you would have to get your compass and you would have to measure it, the width of it, to be 3 centimeters on your ruler. Obviously put the point of your compass around the pond. Now I'm going to use a circle, but obviously you would just draw an arc, right? So let's say I have this. And let's say that, I don't know, let's say that was 3 centimeters, right? So shade the region that the tree can be planted, you should be left with some kind of like region in between. So I think for loci, it's just knowing when to do a line and when to do a circle or like an arc with your compass. Obviously, if it's a certain point, a distance from a point, you need to do an arc. If it's a distance from a straight line, you draw also a straight line, right? So I think loci in itself, like this bit, I feel like it's kind of straightforward to figure out. It's just either a compass or a straight line, isn't it? That one's fairly straightforward to figure out. Maybe it's more so the construction, which is then these ones where they say construct certain things, perpendicular bisector, construct a 30-degree angle, like things like that, bisector of an angle, things like that, that you just have to memorize, and then it would be quite easy. But again, you see they're only kind of 2 marks each, so it's up to you whether you're worried about it coming up or not, really. Question 11 on this. Oh, this one here, yeah. Can you see all of that? Let me just check, so I don't know if it's too small. Oh yeah, you can still see the whole question. So here is a scale drawing of a room. The scale is again 1 centimeter to 2 meters. A chair is going to be placed in the room. The chair must be closer to AB than BC. So where's that? AB's here. Oh, but BC's here, yeah. So that's kind of this corner. And the chair must be less than 14 meters from D. So that's a point D, isn't it? I think the 14 meters is quite easy. So you could go, I'll do that bit first. It's 2 meters, so 14 meters, obviously 7 centimeters. So you'd get your, because you see how point D is a point. What we can do is that would be an arc. Again, I've drawn a circle because I don't have a compass, but you would just draw an arc, right? You wouldn't draw the whole circle. So you would get your compass, the width of it would have to be 7. You'd put it on point D, and then you would draw an arc. So I don't know, let's say that was 7. You obviously wouldn't draw the rest of this, right? Just ignore the rest of that circle. You would just draw this bit that's inside the room. So that'd be that bit. Now, closer to AB than BC. I feel like this would probably be bigger. Let's say that it was like that, I don't know. Closer to AB than BC, because A and B are, well, the AB line, BC line are perpendicular to each other. I'm guessing that would be a perpendicular bisector, right? So you'd have to know how to do that. So we want to cut, basically be able to draw a line that cuts the angle in half. Obviously, you're not going to use your protractor, right, to measure it. They want you to actually, show how you figured it out. So a perpendicular bisector, what we do is you'd get your compass, put it on the point B, because B's like in the middle, isn't it? I don't think it matters how far along, like what your width is. I do normally about 2/3, as long as it's more than halfway of it, I guess. So I draw like an arc here, let's say that's 2/3. And then the same distance, the same width, I would draw it here. So on both A, B, and BC. Then get your compass, same width, put the point on, over here. I don't know if you see where my mouse is. And then you would draw like an arc. That's horrible. you draw like an arc over here as best you can. Let's say that's an arc. And then do the same on this point. And it should cross. Now, obviously, mine's not accurate, as I said. Yours will be accurate. And then you'd get your line, the ruler, obviously. And you see how I could draw from point B to where that crosses? That should technically be, that wasn't even bad. That should technically be halfway, right? So then what do they say? They wanted it to be closer to AB than BC. So that's the left, like above the line, isn't it? That's over here. And then they said it must be less than 14. So in my case, obviously I've not drawn it accurately. Yours, I guess, might have a bigger region. In my case, it would technically be that region there. You might have a bigger region, right, than what I've got, because you will have done it to scale. I've obviously just guessed what the scale was. So that one there was, the first sentence there was a perpendicular bisector. The second bit was, again, just kind of around a point. Just an arc around a point, and obviously using the scale. So okay, so that's, I mean, that's loci and a bit of construction, but as we said, it doesn't often come up, so it's not really one that I would be too worried about. As you can see, it's like 2 marks. You could easily make up the 2 marks somewhere else if you weren't sure. Let's keep moving. Okay, so loci. I think that was a straight line question. June 2020, question 2, June 2023, paper 2. Don't know if I've got a video on that anyway. I'll have a look and see which one it is. June 2023, paper 2. Hang on. Paper 2. Question 22. Yeah. Oh no, I don't think I've been through this one in a video, but yeah, this is one. It's only 2 marks as well, but I feel like it doesn't necessarily make a lot of sense. Okay. If I've missed your question, please post it again so I can have a look, because there's obviously been so many comments. Okay, so I think I've seen one that was similar to this as well. I think this has come up twice and it's quite similar. Obviously the context was different, but it was another 2 marker and it was kind of similar. So there are only blue pens and red pens in a box. The number of blue pens is 4 times the number of red pens. Rita takes at random 1 pen from the box. She records the color of the pen, then she replaces it. Okay, so she does put it back. Rita does the same. She does this n times, where n is greater than 2. So if you imagine a probability tree, that's 1, that's 2, and it's more than that. So it's like either just twice or more. So it could go on forever, couldn't it? You know, if you imagine this tree, it could go on forever. Write down an expression in terms of n for the probability that Rita gets a blue pen at least once and a red pen. So you don't have to draw it out like this, but I'm just going to kind of show you. Just to kind of explain it, really. You've obviously got either, what was it, blue or red. So blue pen is 4 times the number of red pens. So like if you imagine red is x, blue would be 4x, wouldn't it? You don't have to necessarily use algebra again, but I'm just going to use that for now. So in terms of fractions, or you could think of it as a ratio, I guess, you've got 4 to 1, haven't you? So the probability of getting a blue pen, we don't know how many there are, but we know that it's like 4 out of 5, isn't it? And then red is 1/5. So that's kind of, I think you need to know that, just at least that, as you go through. Now, because they've said at least 1 blue, at least 1 red, if I get my highlighter, it would have to be, let's say, blue, then it could be red. Then we don't know what happens after that point, do we? That's the problem. Or it has to be at least red and then blue, and it's going to be all of these zigzag ones. What you have to think about, because we can't obviously account for all of these because we don't know how many times she's done it, we can't account for that. We can't obviously actually work it out. And it says at least 1 blue. Well, we don't know if it was 10 blues and 1 red. Like, we don't know. But what we do know is she does have 1 blue and 1 red. So when I was doing the other probability tree question, you know, when I was saying technically we highlighted all of the options except for 1. So you could work out the one option that it's not and subtract that from 1, from 100%. That's what you would have to do here. So in this case, if she picks a blue one at least once and a red one at least once, the only 2 options that we can't pick, I get rid of my highlighters, we can't have let's say that was blue, 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 blue. She can't have only picked blues. She had to have at least one red, didn't she? Same with red. She can't have picked just red, just red, just red, just red, just red. She has to have picked one blue. So what I would do in this case, because you, as I said, you can't kind of figure out how many of each she got, what I would say is you'd have to just do the 1 minus the 2 options that she can't have. She can't have all blue and she can't have all red, right? So then you go, okay, well, how would I work out the probability of getting all blue? Now, because she does replace it, the probability is the same every time, isn't it? 4/5, 4/5 for blue. And for red, it's 1/5, 1/5 because she does replace it, right? So we don't know how many times she does this. We don't know how many branches there are to the tree. But do you remember how I said you're going to multiply between the branches? So technically it'd be 4/5 times another 4/5 times another 4/5. It's 4/5 times itself. Now we don't know how many times that is. So that would be 4/5 to the power of n, wouldn't it? If you did it twice, it would be squared. If you did it 3 times, it'd be cubed. We don't know how many times, so it's to the power of n. That is the probability of all blue, which we've just said we can't have. That's fine. Now, the probability of all red is the same thing, but obviously the 1/5, and then again to the power of n, because we don't know how many times. Now, let me just rub out my tree. We said those are the 2 options that she can't have, but all of the other options in the tree she can have. All the other possible combinations of that tree she could have. So what I would do is I would do 1 minus the 2 options she can't have. So 1 minus 4/5 to the power of n, and also minus the all red. 1 minus all blue, that's all blue, isn't it, that one there, and all red, because she has to have at least one of each, but she could obviously have multiple of each. So that would be your answer. I don't know if that makes sense. You have to choose the option that she can't have because you can't account for all the possible options that she could have. There's too many. But I've seen another question that was very similar to this. I think it was like heads and tails, something like that. I can see if I can find it on my... Did I paste it on my probability questions? Let me see if I can find it, because it's actually the same. So even though it's hard, if you kind of seen this question before, you might be able to figure it out again. If they come up, if they ask it again, because it's happened twice already, you might be able to figure out the logic. Where is it? I think I did the other one in one of my videos, actually, recently. I think it was in the hardest probability video, maybe. Where is it? Oh, no, I found it. Yeah. It was from November 2021, paper 3. This one. This is basically exactly the same question. Just so you see, again, it's also 2 marks. Yeah, I know, it's only 2 marks, so like if you can memorize the answer, that's probably the easiest thing to do. So for this one, Pat throws a fair coin n times. You see, again, n times. So that's that probability tree that could go on forever. We just don't know. We don't know how many times it goes on for. Find an expression in terms of n for the probability that Pat gets, again, do you see how this is exactly the same? At least one head, at least one tail. Obviously with a coin, you can only get heads or tails. Heads or tails. Now, because it's a fair coin, the probability of getting heads is obviously a half. The probability of getting tails is obviously a half. And every time it's the same, isn't it? It wouldn't affect it. So because I can't account for all the different possibilities, what I can account for is that, Sean, this is basically the same question. So if you understand this one, you'll understand the previous one. Okay. I can't account for the fact that, there's so many different combinations of heads and tails, is there? I can't account for that. I don't know how many times they've done the tree. But what I do know is that they have to have at least one head, at least one tail. So what we can't have is all heads, or what we also can't have is all tails, because it has to be at least one of each. So I'm going to do the 1 minus again. So probability of getting all heads would be a half, and then to the power of however many times they've done it, right? Heads there, half. You obviously half times a half times a half, however many times. The probability of getting tails is the same. isn't it? Because they're both, it's a fair coin. So the probability of getting at least one of each is 1 minus both of those. Do you see how it's basically exactly the same question? Just obviously the probabilities in the context is different. But the wording, exactly the same. 2 marks, exactly the same. So I've seen that happen twice now, so that might be kind of possibly a repetitive question with Edexcel. But if you remember this, then, again, you don't have to obviously draw the probability tree to get the marks, right? That was just me explaining it to you. You get 1 mark for writing down like one of these, and then obviously 2 mark, like the second mark is for writing it fully. So that's your working. Okay. So yeah, hopefully that answers your question. You've got 2 examples that are basically the same question there. Okay guys, I've lost track of the chat basically. So what else did you guys want to go through? If you've mentioned something before and I haven't gone through it, then please remind me. But also, Sean, like, you're doing a completely different set of exams than us, so you've got to obviously focus on how yours are laid out, how yours are worded, how yours are marked. That's very different to how this is marked. It's very different to how even AQA is marked compared to Edexcel. They're quite different as well, even though it's the same country and the same syllabus. So it's probably not helpful to compare yourself to what we're doing here, because I don't know what comes up in your exams. Do you know what I mean? Can I do it without? Oh, I was just doing it to explain it, basically. I don't know how I'd explain it without the tree, to be honest. It's basically, I'm saying that we just have to, because we can't account for all the different combinations of heads and tails that they could get, because I don't know how many times he's going to throw the die. What was it? Oh, the coin. I don't know how many times he's going to throw the coin. So I can't account for all the different possibilities. So I can't calculate it like a normal probability tree. What I can account for, though, is the only 2 options of what can't happen. What can't happen. Because he wants at least 1 head and at least 1 tail, you can't get all heads and you can't get all tails. Right? You can't get all of each. So I did 1, so all of the possibilities is 1, isn't it? Add up to 1. All the probabilities add up to 1, minus the 2 options that I know for certain that it doesn't include. Because I can't account for all the options that it does include. That's the best way I can explain it, really. But this is a very niche question. This is very niche to not just the UK, but also Edexcel. This might not even be asked in AQA. So it might not be asked in your exams anyway, right, Sean? So I don't know if this is even helpful for you to know. I don't know what they ask you in your exams. So, yeah, I wouldn't stress if this doesn't make sense, because I don't know if this even relates to what you need to know in the first place. Yeah. I can have a look at the AQA paper. I'm not super experienced with AQA, but we can give it a go. Question 26 from paper 2019. Is it June or November? Oh, November, you said. November 2019. Paper 1. I'll have a look. We'll see what we can do. Obviously, the syllabuses are basically the same, right, between Edexcel and AQA. It's just how they word the question. Oh, the turning point of a graph, is it that one? Oh no, it's on angles and circle. Wait, I've got the wrong one. What have I opened? Oh, I've opened the June one, hang on. That's not very helpful. Why is that June? November, there we go. Paper 1. It's better. 26. Oh, I can see now, it's, yeah, like circles kind of, and a circle sector. Yeah, this is probably relevant to Edexcel as well. See if I can copy that. This one. This is AQA. You can see the difference in the text and the formatting, by the way. This is AQA. November 2019, paper 1. Okay, so here are a circle and a sector of a circle. They each have radius r. The circumference of the circle is the same as the perimeter. So they've given us an equation of the sector Okay, so when it says work out the size of angle x, this is an equation that I'm going to translate from words into like maths, or I'm going to translate it into an actual equation. So we need to know, actually it's on your formula sheet, but the formula for, let's say the left-hand side, the circumference of a circle, you either know it as pi times diameter or 2 pi r, doesn't really matter which, I'm pretty sure that's on your formula sheet. So in this case, we'll use 2 pi r because there's a radius, right? So that's the left-hand side of the equation, 2 pi r equals, and then here we need to kind of create an equation for the perimeter, right? So that would be, the perimeter is all the sides added together. In this case, obviously there's 3 sides. So you need to know the arc length. I think you need to know that formula. That's not on your formula sheet. But it's based off of, obviously, the circumference. The arc length is the circumference, so let's say we'll go 2 pi r, multiplied by the angle over 360, because that gives you kind of like a proportion of the whole circle. Like, it's not the whole circle, is it? It's not whole 360 degrees, it's a small amount. So in this case, if I sub in actually what I've obviously got the radius, but instead of theta, I'm going to put x, because that's my angle, isn't it, in this case? And I would have to add that to the radius here and the radius here. Or you could write it as 2r, obviously. So do you see how I've just set up an equation that I've translated this into just maths? That's probably the hardest bit. From here, all I need to do, because they said find the size of angle x in terms of pi, because it's obviously non-calculator, I just need to solve. Do you see how the only, well, let's go, the only letter we don't have is x. We obviously have r, but I'm assuming r is going to cancel anyway. I want to get x as my subject is what I'm looking for. So let me just rewrite this. 2 pi r is equal to, this is like, you don't have to write brackets, but I'm just kind of demonstrating. This is like one term, isn't it? Because it's multiplied. That's all one thing, right? And then plus 2r. Now, obviously, to solve it, I only want one letter. The problem right now is I've got r, but you see how I've got 3 terms? All of them have r in it. So what I can do is just divide by r, which would cancel out, because it's in all 3 terms. You can't do that if it's not in all of the terms. So get rid of the r, basically. The r is kind of irrelevant. Now, do you see how the only letter I have left is pi? Pi is x, and obviously pi is a number, so that's fine. So I've got 2 pi here is equal to, now I'm going to multiply this just so that, you know, it's all one thing. 2 pi x, that would only affect the numerator, over 360, plus 2. I'm solving for x now, basically. This is just, you can almost forget about the context. I'm just solving for x now. We can't cancel out the pi, first of all, because they said leave it in terms of pi, that's one clue, but also because that one doesn't have a pi, so we're not going to cancel out the pi. Normally, sometimes you can, but in this case I wouldn't. So I want to get x on its own, so what am I going to do? Probably subtract the 2, let's put that with the 2 pi. Obviously I can't subtract it directly because it's not a like term, you've got a pi there as well. And it's non-calculated, so you're not going to work out what pi is. Multiply by 360, so what's that, 720 pi minus, you could probably put it in brackets, but I'm just going to expand it. 720 is equal to 2 pi x. They haven't said give it in a simplest form though, so I guess they don't really mind in AQA. And then I would divide by 2 pi. Well, you could probably simplify this fraction earlier, to be fair, if you wanted. You could simplify it before that. That would probably make more sense. So divide by 2 pi would then just divide it again, wouldn't it? Over pi. I don't know what the mark scheme says. I think, from what I know from AQA, they're not as fussy as how you leave your answers as Edexcel is, which sometimes I think is worse, because I'd rather just know what they wanted. What was this, 26? I'm going to check the mark scheme. Yeah, they've given 3 options of how you can leave it. You can leave it like this. You could have, you know how I said if you don't expand it, you could have left it like this. You could have split this up and done 360 minus. Any of these answers is fine. Yeah, any of these is fine. But that's actually quite a nice question. As long as you can set up that initial equation, you just have to be able to set that up. But technically, you know, the circumference formula is on your formula sheet. The arc length, part of it is just the circumference, and the other part you just need to know. You just have to memorize that, right? That you times it by the angle over 360. Same with the area of a sector, do pi r squared times the angle over 360. And then you just obviously piece it all together. Once you've done that, it's just rearranging. After that, it's literally just rearranging. Okay. Sean, that's just what they call teachers in the UK. To be fair, I'm not a teacher, so you don't have to call me that, but technically that's what you would call a teacher in the UK, so it makes sense. Okay, guys, anyone else have another question? We've got probably about 15-20 minutes left that I haven't seen. Anyone else have another question or another topic they wanted to look at before we finish? Just say it again if I haven't read it properly. Ideally something related to GCSE maths if possible. Anyone else got any more questions? The probability one. I tried to explain that as best I can. I don't think that's relevant to GCSE, to be fair. "3D shapes and volume." Oh. Do you have one in particular, like a particular shape? Or it could be anything. Geometry shapes. Like, do you want prisms, which is, you know, cylinders, triangular prisms, cuboids, or do you want ones that aren't prisms, which is, you know, cones, spheres, hemispheres? I feel like there's a bit of a difference in those, isn't there? Maybe prisms, because that one you actually have to work out, don't you? The other one they give you the formulas for. Volume, where is it? Here. Yeah, Sean, I realize you don't understand. I've tried to explain it in like multiple different ways, so I don't really know what else to kind of say. Like I said, it's maybe not relevant to your syllabus anyway, so any should do, that's fine. Maybe something like this. It's only question 9 though, to be fair. On Edexcel there doesn't seem to be a lot of volume of a prism. I think Edexcel is mostly cones and stuff. I guess because that's harder, isn't it? This is 5 marks though, so it's quite a big question technically. And you've got angles as well, so that might be interesting. Okay, so we've got a prism. Prism is where obviously if you cut through it at any point it'd be the same shape. This one's obviously like compound in the fact that we've got a cuboid and a triangular prism kind of stuck together, so it's created like a compound shape. So the cross section of the prism has exactly one line of symmetry, which you can obviously assume is down the middle, isn't it? Work out the volume of the prism. So what they're saying is the triangular prism is effectively an isosceles triangle, isn't it? That's why they're saying about that symmetry. Volume of a prism. Now I'm pretty sure that's on the formula sheet, but it's quite general. It's saying volume of a prism. They don't say which type of prism, so you'd have to apply it more specifically. Obviously, the volume of the cuboid, I'm going to do separately to the triangular prism. Now, the cuboid is the easier one, isn't it? Because you've got all the measurements there. The volume of the cuboid is just those 3 basically multiplied together, because they're 12 times 10 is the front face, like the cross section, and then you multiply it by 20. So that bit's quite easy. You can always get that straight away. What was this? This was also calculator, so you could probably work it out yourself, but you might as well use the calculator if it's a calculator question. So that's the volume of the cuboid. Now I obviously need to know the volume of the triangular prism, which would be half base times height of a triangle, wouldn't it? So the problem is that we need to know the height, which is why they've given us this angle. So what I would do, because it's an isosceles triangle, because of the fact they said it has a line of symmetry, where I've drawn that line is the line of symmetry, isn't it? I could split this into a right angled triangle. Now, because that's exactly halfway, I know the base would be 5, because you see how that was 10? 10 up here, then half of it's 5. And I want to know the height, so I could just use SOHCAHTOA there. So I want to know the opposite. I do know the adjacent, so that's tan, isn't it? TOA. So I want to know the opposite. So I would have to do tan 40 of the angle times by 5. Which I'm assuming is going to give me some decimals, but that's fine. Yeah. That gives me, if you type that in your calculator, obviously this is a calculator question, ... loads of decimals. So then we can do half base times height. So the area of that just 2D triangle, think of the whole thing now, I'm not splitting it in half anymore. Half times the base, which the base as a whole is 10, I'm taking the whole triangle, right? Times by the height, which is the 4.915, which I would keep in my calculator, times by 10 times by 5, half, gives me 20.977 ... And then to make it into the volume, we have to multiply it by how far back that face, that cross section, repeats itself, which is the 20, isn't it? So I would take my 20.977 and multiply it by this 20. Which is 419 loads of decimals again, right? Oh, that's meant to be a 4, 9, ... Now, the volume of the prism is then those two added together because they're two separate prisms, aren't they? So add those together. You should get 2819. Now, what do they say? Three significant figures. So now I can round it. I don't like to round anything until the end. I know AQA is not that fussy about rounding, so you might not have to worry. Edexcel is a little bit more fussy with the rounding. So 3 significant figures would be 2820. 2820. Obviously, don't miss out the 0 at the end to make the scale. So that's a prism one. Obviously, they might make you use other things if they don't have the correct sides there. You might have to use, like as we did trig here, different things to work out the side lengths if they're missing. That's how they could make it a bit harder. Yeah. Let's say we could do a cone one that's not a prism. Let's do one of those. I realise these aren't AQA ones, but obviously that it's, you know, the maths is similar, isn't it? So I think they're more likely to ask cones and spheres because it's a bit harder. Let's pick a good one. There's one there, but actually we're going to do that later anyway, so let's not do that one. I'm trying to find a frustrum one, because that one I think is more helpful, but anyway. Let's just do this one here. This has got a cone and a hemisphere. Now, same with AQA, they will give you these formulas. If it's not a prism, so these are obviously not prisms, right? It will give you the formulas for them, not necessarily on the formula sheet, but in the question. As you can see here, they've given it to us in the question. So question 17, now this is only 4 marks, but it is question 17. This is from the June 2022. Again, this is Edexcel, I realise, but for those who are doing Edexcel, you can have a look at it. So you can see here a solid cone is joined to a solid hemisphere to make the solid T shown below. So that's this whole thing here. Now they're giving you the volume formulas. Just be careful. I have seen this in AQA actually. Sometimes they give you the volume of the whole sphere, which they've done in Edexcel, they always do this. Do you see how we've only got a hemisphere, which is half? So you'd have to remember to half it. Sometimes in AQA they give you the whole volume of the sphere. Sometimes they give you the hemisphere formula. So you just be careful, just double check what they've given you with AQA. I know it differs depending on the question. With Edexcel, it's pretty much always the whole sphere and you have to remember to half it. Okay? So the diameter of the base of the cone is 7. Now this is another really common thing, is that they will give you the diameter when obviously all of the formulas are based in the radius. So just, again, that's another thing. Because obviously substituting stuff into a formula is really easy. The way they've made it harder is by giving you the whole sphere, so you have to remember to half it, and also giving you the diameter. Instead of the radius, you have to remember to half that as well. So there's just all these details you have to remember, basically. So the diameter of the base of the cone is 7. Obviously, that's the same diameter for the hemisphere. The total volume of T is 120 pi. This is paper 2, but they've given it in terms of pi anyway, so you probably don't necessarily need a calculator. And then the height of T. So you see how the height is the whole thing, not just the height of the cone. So just be careful of that. Because obviously in our formula, there's the height of the cone just on its own. So just, again, trying to make that distinction. Is y, calculate the value of y. So we need to find out the height of the whole thing, which means the height of the whole thing is split, isn't it, into the height of the hemisphere, which is effectively the radius, isn't it? So that's fine. We already know what that is. And then the height of the cone. So do you see how that tells me that I'm going to have to work out the height of the cone? And then I'll obviously add the radius, which is 3.5. So again, we're setting up a formula here based on the volume of T. So the volume of the whole thing would obviously be the volume of the cone, pi, a third pi, r, which is not 7, 3.5. Remember to half that if they've given you the diameter. And then the height of the cone, which I'm going to use h because obviously it's not y, is it? Plus the volume of the hemisphere, which is the volume of the sphere. Again, remember the radius. Oh, no, that's cubed, isn't it? But I only want half of that because it's a hemisphere. Now, do you see how that equals 120 pi? So again, it's kind of similar to the one that you showed us on the AQA one, that you need to set up an equation yourself. And then I just need to rearrange it because you see the only letter I don't have is h. So I can solve it for that. It's quite complicated, but I can solve it for that. Now, okay, yeah, this is a calculator one, I guess. I'd probably do that. What I would do in this case, you see how in the other question I said sometimes you can cancel out pi? There's 3 terms here. They all have pi. So I'm just going to get rid of the pi just to not deal with the decimals there. Now, I'm probably going to work out the 3.5 bits. 3.5 squared. Assuming that's not a great number. I'm probably going to keep it in terms of fractions, just because I don't want to round anything too soon. Times by a third, that's just that first bit. 49 over 12. Now, you could write it, but you see how that's like a recurring decimal, so I'm not going to write the decimal, I'm going to write 49 over 12. And then that's the h bit, isn't it? So I've worked out this bit here. That's the bit I've worked out. And then over here, let's do the same for that one. So we've got 4/3 multiplied by 3.5, but that one's cubed, isn't it? Cubed. And then I want to divide that by 2. So 343, again, not a nice number, but you see how the other one, the decimal's worse. So I'm going to keep it as a fraction. 343 over 12. No, actually, that's just a number, isn't it? So that's fine. Equals 120. I don't know. I don't know if Discord... do people in the UK use a Discord? Because obviously my content is mainly for people in the UK, right? So... any of you guys, would you guys use a Discord server? Okay, so now you just have to solve it. So I could subtract the 343 fraction, couldn't I? Again, being that this is calculator, I'm just going to subtract it straight away. So 120, oh, what's it good? Minus, I'm putting answer because my previous answer was that, wasn't it? Again, I'm going to leave it as a fraction just so I don't deal with any decimals. So that's 1097 over 12. And then I can divide by this fraction. Obviously, if it was non-calculator, I'd do it in probably a different order, but it's not, so it's fine. Okay, that gives me 1097 over 49 for the height. Now, just don't forget what you were actually trying to do, because I know this was quite a lot of working, and it can be quite easy to forget. Let me just check, was that right? Yes. It can be quite easy to forget what the whole point was, because we've solved the equation. Now, the thing is, though, that the height, that's the height of the cone, remember? That's why I drew it up here. I don't actually want that as my answer. What I want is the height of the whole shape. Do you remember how I said we need to add the cone height plus the radius? This bit here is like a radius, isn't it? The radius is 3.5. So therefore, just don't forget, when you've done loads of, complicated calculations, is that actually the final answer, or was there something else I needed to do? That's 3.5. Now that I'm getting to the end is when I will finally actually look at the decimals, but I don't tend to look at the decimals until right at the end, just so I can get the most accurate answer. Now I can look at it. Now they have said 3 significant figures. Again, I know AQA doesn't tend to. Yeah, I don't know how you ban. I can put him on like a. No, because the other guy always interacts really well, Sean. You're just kind of spamming it now. So, I mean, we're going to end this live in a minute anyway, but it's not helpful if you're going to just keep spamming questions. So, in this case, it should be 25 to 3 significant figures, 25.9. That would round up, wouldn't it? Now, I know AQA, they don't really tend to tell you how to round it, so they wouldn't really mind how you gave your answer, I don't think, but they'd give you like a range. But yeah, that's another kind of volume one, but one where you had to solve it, like rearrange and solve it, rather than actually finding the volume. So, yeah. No, it's because he normally interacts really well. That's why I'm not, like, he's actually here to kind of learn. When drawing a cumulative frequency graph, are you allowed to do dot to dot? What do you mean by dot to dot? It has to be like a smooth graph, like a smooth curve. It's not like straight lines. I don't know if that's your question. Like, it has to look something like that. So you obviously try and join up the dots, like the crosses, right? It's just because your questions aren't really related to what everyone else is here to watch, Sean. That's the only reason. Like, you can obviously have a look at. I'm sure loads of people do lives on. What was it? The SATs that you're doing. I'm sure loads of people do lives on that. But I tried to explain the probability to you, but didn't understand. Oh, sorry. What was your question? Oh, the straight line one. Yeah. I'm not sure what you mean by from dot to dot. It's obviously not a line of best fit. Like, you have to go through the dots, right? You have to connect them all up, right? Like, if you had a, here and then here, you have to connect them, but it has to kind of create a curve. I don't know if that, like, it, it's not like going through, it's not a scatter graph, right? It's not a line of best fit. I'm not really sure if that answers your question, to be honest. So, like, yeah, I would join them all up kind of exactly, but it needs to create like a nice kind of curve within those dots. If I don't know if that answers the question. Oh no, it shouldn't be straight lines. So cumulative frequency is a curve. I don't know if you're thinking of frequency polygons, which is kind of like a very similar thing. In that case, a frequency polygon is like straight lines and it kind of looks a bit jaggedy, like, I don't know, like that. That's frequency polygons. That's a different topic. They do sound the same because obviously they're both based on a frequency table, but it is a different topic. Cumulative frequency is always a smooth curve, and then frequency polygons is like straight lines where you join each point up with a straight line and it creates this kind of weird jaggedy kind of drawing. I don't know if that's what you mean. So it's just being aware of like the two different topics. They are technically different topics. Yeah, line segments. That would be for probably frequency polygons is what I'm thinking. Yeah, so I'm gonna just do this last question on the straight line one that you've said, and then we'll finish because I need to do my next paper. It was 18 marks on a practice paper. Are you sure? That looks like well, I don't know if you're doing GCSEs, normally GCSE the maximum marks is 5 or 6. So 18 seems like a lot. Yeah. So the straight line passes through point A. I'm just going to do this quickly and then we'll go on to our actual past paper. And point B is 5, 3. So it's a straight line. Straight line M is perpendicular. Hang on, where has it gone? Perpendicular to L. This is L. L goes through those ones. Perpendicular to L and passes through the midpoint of A. A and D? Do you mean A and B? Or is D as D as separate coordinate? The line N intersects the line x equals -1 at C. I think you mean D specifically, don't you? Do you mean D or do you mean B? Sorry, I think there's only meant to be B. I'm assuming you mean it goes through the midpoint of AB, right? Oh, so it will allow it if you did it in straight lines. Maybe it will allow it, but I would, from what I know of cumulative frequency, it's always a curve, so I would recommend doing a curve. Maybe it will allow a straight line, but the technical thing for cumulative frequency should be a curve. Okay, hang on, right. So it crosses through the point A and B. Yeah, it's a straight line there. Okay, normally for these ones I kind of draw a little sketch just so I can get a rough idea of what is going on and, like, you know, just the direction of everything. So A roughly -6, 2, let's just put that there, right? That's A. B is then 5, so that's probably about here, and 3, so let's say that's there. So obviously then you've got the line, make my line a bit smaller. So this is line L. M is then perpendicular to that at the midpoint and crosses through at -1, x is -1. Line x is -1 is, let's say that's -1, right? That's the line x is -1. So, and you want to work out the area of triangle ABC. So I'm going to roughly draw. So it's a half. So I'm going to draw a line M. Again, this is kind of rough. I think it would be like that. Okay, so it probably crossed through up here. This is rough, right, guys? This is obviously an estimate, just so I can get an idea of. I wanted to move that one. Extend this one here. So triangle. So then that's C up there. So triangle ABC is this. That's kind of my estimate of what we're looking at. We want the area of this. Yeah, I guess that is quite a lot. That's meant to be an x-axis, y-axis. That obviously looks horrible. Let me draw that again. This is the y-axis. Oh, no. Thought that would move it. I'm just going back pages. Again, this is not to scale, this is just my like rough sketch is probably what I would do in the exam. Okay, so obviously area of a triangle, you want base times height, so we need to know the length of AB and then the length of, like, from here to C. So the length of AB, I guess, would you use Pythagoras normally because it's diagonal, isn't it? You can create like this triangle here, can't you? And it's the hypotenuse we want. So the difference here is 11 across, and then the difference up is 1. So AB would be the square root of 11 squared plus 1 squared, which I would probably leave as a 122. Or does it simplify? No, it doesn't. Obviously it's decimals, but I would probably leave it like that just for now. Okay. So that's AB, that's technically the base of your triangle, isn't it? And now we want to know, is obviously more information about from the point here to the midpoint of AB up to C. So I would need to know the coordinates of C and the coordinates of the midpoint. The midpoint of a line, midpoint, you just add them together, as in the two, so the two x's and then half it. Same with the two y's. Oh, if you can't, you can obviously figure it out yourself if you want to. And then half it, that's how you use like an average. So that would be -1/2, so -1/2. And then that would be, what, 5/2? You can put it as decimal if you want, but that's fine. So that would be this point here. the midpoint is, I'll put MP, MP is here. And then obviously I've not drawn it really to scale. Remove this, the y-axis will probably be over here somewhere. And then we want to know the coordinates of C. Now we know that the x coordinate of C is -1 and it's on the line M. We haven't used the information that they're perpendicular yet, so I guess would we have to find the equation of line M? So we'd have to find the gradient, which is M, gradient of AB, or L, which is change in y over change in x, so 3/2/5 minus 6, 1/11, that's not a very nice number, but anyway. Then the perpendicular gradient, so the gradient of M, line M, would be perpendicular, which is -11, negative reciprocal. You can see it's negative, so that's good. Then we want to find the plus C, so y equals -11x plus C. Now this is where you'd have to sub in a set of coordinates that's on that line, so we now know the midpoint is on that line, isn't it? So you could sub in the midpoint. I can see why this is a lot of marks, I guess. Yeah, that does make sense. I don't know if you can still see my writing here, hopefully. It's not too low down. I don't know if this was a calculator or not, but so that would become 11 over oh, we're drilling. Great. Okay, hopefully they're not going to be drilling the whole way through our next live. So that's the equation of line M there. Now, I want to know the coordinates of C. So I know -1, right? X is -1. Sorry, this is not in any kind of order. I'm drawing arrows so you know where I'm going. Okay, so this coordinates of C is -1, 8. So now you could find the height by doing, again, Pythagoras. We're going to have to just be late for our next live in a minute. So here, that's meant to be a right angled triangle. Again, the side that I want is the hypotenuse, so I'm going to call that the midpoint to C, right? That's that side. Hopefully you can see what I mean by that. Would be, the midpoint was -1/2, so -1/2 to -1, so that's a half, isn't it? Squared, plus the height started at 5/2 and went up to 8. So 8 minus 2.5 is 11/2 or 5.5. I'm assuming this is definitely calculator. Which gives me this. I'm just keeping it without the decimals. So now I've got my base and my height of my triangle, right? So now the last thing, sorry about the hammering, didn't know they were going to start that. Area of ABC is base times height over 2, or half base times height, half base times the height, which I'm just going to type in 0.5 times that times root 122. Oh, actually gives you a decent number. I got 30.5. I don't know if that's right or if I've made any mistakes throughout this, but obviously I'm trying to do it, you know, quite quickly. That's what I got. So you can obviously confirm if that's the answer that you should have got. But either way, it's a mixture of basically finding out midpoints, finding the equation of a perpendicular line, Pythagoras. You can use a lot of Pythagoras when you've got diagonal lines to find the hypotenuses, and then area. So it's kind of all those different things, right? Okay. It's just because, Sean, like, the questions you ask aren't relevant to everyone else who's watching the live stream. That's the only thing. Like, if you obviously want to ask questions on the SAT stuff or whatever your maths is, that's fine, but it's best if you find a live stream where they are going through that stuff, because I can't really help you because I don't teach that, right? It's not helpful for you and it's not helpful for everyone else. So You got the same? Okay, perfect. All right. Okay, right, guys, I'm going to have to finish this live stream because I've got my next live stream like 2 minutes ago, which is on actual past paper. So if you're doing, if you're actually doing Edexcel and you're doing higher tier, it will be paper 1. June 2019, we'll be going through that. If you're not doing Edexcel, it's probably not massively helpful to you, but anyway, so I'm going to leave the live stream here. Gina, you can, but obviously I'm going to be going through a paper, so yeah. I will have more of these Q&A sessions throughout the week anyway. So there will be more, okay? Yeah, I think my email's on my... I think you can find it on my channel. If not, it's just the same as my channel name, GCSEMathsPro, and then at Gmail. So you can send me an email if you've got questions. Yeah, that's fine. I think it's on my channel, but it's the same channel and then at Gmail, right? Okay, guys, I'm going to basically try and set up the next live, which will be on the past paper, okay? So anyone who wants to have a look at that, then I'll see you there.